Let's take a look at example 7.2 from our textbook. It is about the central limit theorem. So when to apply the central limit theorem, we must understand the question. So the question is, the length of time in hours it takes an over 40 group of people to play one soccer match is normally distributed with a mean of 2 hours. So the first step is understand what's given to us. The mean of the normal distribution is 2 hours, and the standard deviation equals 0.5 hours, and a sample of 50 is drawn randomly from the population. Now the question asks us to find the probability that the sample mean. So because we want to find the probability of sample mean, not the mean, but the sample mean. So underline this, sample mean. That's when we call for the central limit theorem. So we want to find sample mean x bar is greater than 1.8 but less than 2.3. So then we will apply the central limit theorem to solve this problem. What does the central limit theorem tell us? It tells us the sample mean x bar, okay, we need to remember the symbol, is normally distributed with mean the same as the sample, the mean of the normal distribution, but the standard deviation is sigma over square root of n. So that is essentially what the central limit theorem tells us. So understanding this, we will apply our technique for finding probability using a normal distribution, right? So normal distribution. So then in the second step, you have two routes. Many of you have TI 83 or TI 84. So what you need to do is just call for this function, normal cumulative distribution function of, so what the first thing you need to enter is x1, x2, so the data point that you're interested in from left to right, the mean, and which in our case is the mean of the sample mean, and the standard deviation of the sample mean. Okay, the subscript is just to specify. This is a little bit different than what is given to us. When we do not have a subscript, those are the population parameter. And when we have a small subscript, those are the perimeter that we discover using the central limit theorem. But if you're familiar with the textbook, if you read all the examples, you will realize those are the things that you need to enter, right? Just consider as the mean and the standard deviation. So the first point, the left point that we're interested in is 1.8. The right point is 2.3. And then the mean is 2 given to us, or we can find out from the central limit theorem. And the standard deviation, we don't know yet, but we can just enter it as an expression, 0.5 divided by square root of 50. Now we do not calculate it and then enter it in here, because it's more accurate if you just enter the expression. So in that case, your calculator will give you an area, and we usually round the probability to 4 decimal, 0.9977. And 4 decimal is consistent with our Z table. And that's the second route you can use if you don't have a TI-83 calculator. So in this case, we have to standardize the Z-score, because the z-table only tells us the probability of x, or of a z-score, not x, of z less than a number. Okay, so what we need to find out is z1 and z2, and we use a formula mu of x subtract mu divided by sigma, and in this case is sigma divided by square root of n, because that is our standard deviation for the sample mean. So now we plug in the numbers. We have 1.8 subtract 2 divided by 0.5 over square root of 50. And you need to understand how this is calculated. Okay, you need to know how to enter this into the calculator correctly in order to get the correct answer for the z-score. And for z-score, we run it to 2 decimal because that's all the table can give us. The accuracy is up to 2 decimal. So that is negative 2.83. So make sure you carry the negative sign. So for the second z-score, we follow the formula. Again, the number we're interested in is 2.3. Subtract the number 2, which is the mean, divided by 0.5 over square root of 50. So if you enter correctly in your calculator, you should get 4.24. So those are the 2 z-scores that we need to look up in the table. Now, if somehow you calculate this before you realize that, oh, I can use my TI-83 to do the calculation, well, then all you need to do is just, and you can also try it out, call the normal cumulative distribution function. And you just enter the z-score 2.83, 4.24, and the standard normal distribution, right? The z-table tells you the standard normal distribution with mean of 0 and a standard deviation of 1. So in that case, you enter 0 and 1. You should still get the same result, 0.9977. But if you do not have the calculator and you're looking into the table, what you will need to do is to look for the row. So our first z-score is negative 2.8, and look for the column 0.03, negative 2.83. So it will correspond to the number 0.0023. Now for the next z-score, you need to look for the row 4.2 and the column of 0.04. We do have that column, but we do not have that row, okay? You don't see it. But you know it's a big z-score. So in that case, when you do not see the area and you saw a big z-score, it corresponds to the area 1. Now, if in another case you want to look up row negative 4.2, in that case, because it's negative, it will correspond to an area of 0. Because if you draw the picture, you know 4.2 is all the way to the tail right here. Okay, so all the area to the left of it should be 1. So if you draw the picture, you should have the realization, even if it's not on the table. So then the probability for our sample mean between 1.8 and 2.3 will equal the big area subtract the small area. You still get the number 0.9977. So that's how we solve problem using the central limit theorem and project it back to the z-table, standard normal distribution, to help us find the answer.